All right, 6.3 is called nth roots and rational exponents. I split this up into 2 days so that we can focus on the radical expressions today, and we're going to focus on the rational exponents tomorrow. Okay, so when you are thinking about inverses, the square root of a number and squaring it are inverses. Okay, so when you square a square root, those operations undo one another. When you take the square root of a square, those operations undo one another. Okay, and so when you are taking the nth root, that undoes the nth power. Okay, so the inverse of raising a number to the nth power is finding the nth root. This value of n is called the index. So we've been working a lot with square roots. We've even been working with cube roots when we did our perfect cube factoring patterns. Okay, so when you are doing your work today, we're going to branch out and we're going to look at different roots. Okay, so the value of n is called the index. The value of a is called the radicand. Okay, so the nth root of a. N is the index, a is the radicand. Now it says, what does it mean if you don't see a value for an index? If there's no value here where n is, what does that mean? What type of root is it? It's a square root, exactly. Okay, so the index is 2 because it's a square root. Okay, so just because we learned that that's called the index does not mean we're going to start writing the square root in different forms. Okay, so do not write you're not going to write that. Cross it off. No, it is the square root of a when the n value is 2. Okay, do not start putting the 2 in there. Now, some numbers have more than one nth root because there is a positive and a negative solution. That happens when you have an even index and a positive radicand, a positive value underneath. Okay, this positive root is called the principal root, and that's the only root that we're going to find today for even functions. Okay, so when you're simplifying even roots, we will only find the principal value. And that's actually a little bit different than what your textbook does. The textbook has you write down the plus and the minus. And so we're going to be doing some worksheets and we're not going to worry about that. Okay, we only are going to worry about the sign if you have an odd root. Okay, so when you're evaluating these without a calculator, if it is even, okay, an even index, we're going to find the principal root, okay, which is only the positive root. You don't have to worry about the plus or minus. I'm just going to, sorry, wrong way. Do that. Okay, and then what we have to remember is how to do our factor trees. Now, a lot of times I have you cut it in half just to make some of these quicker. You guys know that 64 is 8 times 8. And because we've been working with perfect cubes, we should also know that 8 is 2 times 2 times 2. Okay, 2 times 2 times 2. So what you've done is you have broken this down so that now you can see that 64 is the same thing as 2 to the 6th power. because there's 1, 2, 3, 4, 5, 6 2's. So if you take the 6th root of 2 to the 6th, what are you left with? 2. Okay, so the 6th root of 64 is 2. Another way you can think of it is you can take out a group of 6. If your index is 6, you want to find a group of 6. Okay, and when you get a whole number here, this is a perfect 6th root. Okay, if you have an odd index, with a negative radicand, you are going to have a negative solution. And that's because if you have a negative times a negative times a negative, it is going to end up being a negative value. Okay, you really don't have to worry about the negative until you've done the factor tree. Okay, and some of you actually might know that right away. That's fine too. Other people aren't, so we are going to do the factor tree. But again, when you're doing the factor tree, if it's 64, we just did it, right? 8 times 8, which is 2 times 2 times 2, 2 times 2 times 2. So because the index is 3, we are looking for groups of 3. When you have a group of 3, do you guys remember what you do? Yep, so if you have a group of 3 2's, a 2 comes out. Okay, I'm going to put the negative in front because we already said our solution is going to be negative. Now there's another group of 2's. So another 2 comes out. Your final answer would be negative 4. Okay, so this is a perfect cube root. Okay, like I said, some of you might remember that because we did work with perfect cubes. You can also think of this as, this would be the cube root of negative 4 cubed. Negative 4 times negative 4 times negative 4 is negative 64. Those undo each other. That's why you get negative 4 as the final answer. Okay? All right, so for this last one, we have an odd index with a positive radicand. So you're going to have a positive solution. Yeah. And you're not even going to have to worry about the negative with the evens, because if you did, it would be imaginary, and we're not going to deal with that in this section. Okay, so if you had a negative under an even root, okay, well, because we dealt with it in past sections, right, where you had to solve and you would get an answer with I in it. Here we're just going to be simplifying, so there's a lot of other stuff we're going to be working on. We won't have to worry about imaginary values for this. Okay, and then when you are making your factor tree, I encourage you to see if it's even, to cut it in half. And if it's not, then you have to see if 3 goes in there. If you add the digits together and 3 goes into that, it also is going to go into 243. So 2 plus 4 plus 3 is 9. 3 goes into 9. It'll go into 243. This one's actually pretty simple because 3 goes into 24 how many times? 8. And then 3 goes into itself once. And then 81 is just 9 times 9. 9 is 3 times 3. Okay, so then 243 is 3 times 3 times 3 times 3 times 3. Okay, that's the breakdown. So you're doing the 5th root of 3 to the 5th. So your final answer is going to be 3. Okay, so this is going to be a perfect 5th root. Okay, so when you broke it down, you got the 4 3's here and this 3. So 3 to the 5th. Okay, so we saw a perfect cube root, a perfect fixed root, and a perfect fifth root. What's that? No, it's because sometimes they're going to be perfect and sometimes they won't.
So how are you going to know to divide it?
That, yeah.
Well, you're just going to have to like make 50 factor trees.
No, I always start, so what I said is I always start with 2. So if it's even, start with 2. If it's not even, see if 3 goes in there. If 3 doesn't go in there, do you guys know what you would try next? 5. See if it ends in 0 or 5. Okay, if that didn't work, then you try 7. And then you would just keep going. Okay? So with your properties of radicals, when you are simplifying, that value underneath should contain no fractions, okay, and no radicals should appear in the denominator. Okay, so we're going to use 2 properties to help us with this. One of them is going to help you pick out the perfect values. So we've been doing this with square roots. Now we're going to extend it to different types of roots. So I have the cube root of 16 here. I can rewrite that as the cube root of 2 other values. Okay, we've worked with perfect cubes a little bit. What's the first perfect cube? Well, it would be 2 to the third, which would be 8. Does 8 go into 16? Yep, so one way you could do this, you could also factor tree. Okay, but what's the cube root of 8? 2, so it's 2 cube root of 2. Okay, this is very, very similar to something that we've already done. It just looks a little different now because you're going to have different radicals. Okay, so with the perfect squares, right, we've been doing this for a while. If you have the square root of 50, that simplifies to 5 root 2, right? Well, that comes from root 25 times root 2. Now we're doing the same thing, but with different index numbers. Okay, so that rule that we used is, you have the nth root of a times b, you can break it up into multiplication. Okay, so for the second one, if you have a fraction, you're going to split it up into the square root of the numerator over the square root of the denominator, and you're going to simplify. So you have, this is a square root, so we should feel pretty comfortable with this. Root 25 over root 16. Okay, and so square root 5 over 4. Okay, so now we're just going to write out the rule. So whenever you have a fraction in the radicand, you're going to split it into the numerator and the denominator, and then simplify. Okay, so what do you need to do if the denominator contains a radical? So how? What do we call that? Yep, a lot of times you've been multiplying by the denominator. What's that called? Rationalize. Because what we're doing is we're making it a rational number. It's irrational, and we're making it rational. So if the denominator contains a radical, you're going to rationalize the denominator. Okay, so I want you to rationalize the denominator for 2 over root 5. All right, so yep, we're going to multiply by, what are we going to multiply by? Root 5 over root 5, yep. Okay, and the reason why is because when you multiply these together, guys, people are trying to concentrate, so I need you to stay quiet. We're going to be doing a lot today. Okay, so when you're taking the square root, it undoes the power of 2. Okay, we've also talked about how it represents the square root of 25. The square root of 25 is 5. Okay, when you have these opposite operations, they are going to undo that operation. Okay, and we're going to be extending some of these things that we've already been working with. Okay, so we're going to simplify each expression. It says assume all variables are positive, and that's because if you don't, then you have to use the absolute value. And again, I just think that's too much for our introduction to this, so we're just going to assume that all variables are positive and we won't have to worry about it. The reason, nope, we're not going to do it at all this year. Okay, the reason why I'm telling you that is if you use your book for some extra practice, you go to look up the answers in the back, they will look a little bit different than what we've been doing. They're going to look more complicated. Okay, so we're going to start off with a square root. We have the square root of 81 x to the 12. Okay, so I'm going to walk you through this one, so just stay with me. Okay, the first part you are going to know how to do. So when you have a number and a radical, you have the square root of 81 times the square root of x to the 12. Okay, now the part that you're going to know how to do is the square root of 81 because that's a perfect square. So we know that the square root of 81 is what? 9. Okay, now for the second part, I'm going to visually show you what we are doing here. When you are taking that square root, okay, we're going to write this out. Okay, if you have x to the 12, you're going to have 12 x's underneath your radical. We're not going to write this out every time. We're just going to write it out this time and another time to help you with some visuals about what's happening. And then you're going to be able to use your patterns. Okay, so remember that the rule is whatever your index number is, you want that group to be taken out. Okay, so your index number, if you can't see it, is what? Your index number is 2 because it would be a square root. Okay, so anytime there's a group of 2 x's, 1 comes out. Okay, and that's because you're doing the square root of x squared. And what's the square root of x squared? X. So that just keeps happening. So again, I have 2, that's going to come out. I have another group of 2, that's going to come out. Another group of 2, that's going to come out. Guys, I need you to be quiet so other people can concentrate. Okay, and then once you calculate these, you have x times x times x times x times x times x, which is x to the 6th power. Okay, so your final answer is 9x to the 6th. Okay, when we go over this, I'm going to have you think of it this way. Whatever your index is, you can just ask yourself, how many times does 2 go into 12? 2 goes into 12 how many times? 6. That's going to be your exponent. Make sense? All right, then for part B, you have the 4th root of 81x to the 12. So your index number has changed. We are still going to split this up because it's nice to work with the number separately from the variable. Okay, and I want you to just write down what this first part's going to be with the variable. based on what we just talked about. Right? So using the logic that we talked about here, you can just ask yourself, how many times does 4 go into 12? And how many times? 3, so we got x to the third, and it looks like most of you got that. Okay, now for 81, it's not 9 because it's not the square root, it's the fourth root. So we could do our factor tree. Some of you might know the fourth root of 81. Okay, others of us are going to do the factor tree. So you can split it up with 9 times 9. That's probably the one that comes to your mind first. Okay, so that means that 81 is the same thing as 3 to the fourth. And what happens if we do the fourth root of 3 to the fourth? Yep. So your final answer is 3x cubed. Okay, and if you know the fourth root of 81 is 3 right away, you don't have to write it like this. I just want to show you why the fourth root of 81 is 3. Okay, these are canceling out. All right, so those are both perfect values. They're not always going to be perfect. Okay, so we have the cube root of x to the 8th. Okay, so we're going to start this the way that we did with our other questions, where we're asking ourselves, how many times does that index number go into the exponent? So if your n is 3, okay, you can ask yourself how many times 3 goes into 8. Okay, 2. So remember that, because that's going to be part of our final answer. This is also a great one. This is the only other one we're going to be writing it out for, so that we can visualize what's happening here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if your n value is 3, you are now looking for groups of 3, not groups of 2. Okay, so if there's a group of 3, I want you to circle it, and then an x comes out. Okay, so you have one group of 3, and x goes on the outside. Another group of 3, another x goes on the outside. These two are stuck inside. So how do I write that? How do I write x times x? X squared. Okay, so this is going to be x squared times the cube root of x squared. X squared times the cube root of x squared. Okay, so yes, that definitely looks different, but that is correct. One thing you need to be mindful of is making sure that this index number sits right here in this root. Don't put it on the outside so that it looks like it's 3 times. It has to be in that right position there, okay? All right, and now we have the fourth root of 32. Okay, so your index number is important. That's how many factors you need in order to take something out. Okay, so go ahead and factor tree 32. So do your factor tree for 32. You can do that however you want. You can start with the even number with 2, or you can use another combination. All right, once you've done your factor tree, anytime there is a group of 4, okay, that's going to come out. If there's any factors left over, that's going to stay inside. So when you get up into some of the bigger numbers, sometimes it is easier to just keep them here, okay, or circle them all together. So you have one group of 4, and then 1, 2 left. So remember, this group of 4 is 2 to the 4th. So you're doing the 4 through to 2 to the 4th times the 4 through to 2. What happens when you do the 4 through to 2 to the 4th? You get 2, so it'll be 2, 4 through to 2. That's how you write your final answer. Okay, again, we need to just be careful about how we're writing some of those. So make sure it's clear. Okay, and then let's start part E. What? B to the 5th, yes. And then the index is 3. So if you haven't started already, we should be starting that factor tree. Okay, this would be one where it's even, so I would start by cutting it in half. Half of 128 is 64. Once you get to 64, just do the 8 and 8, because you know those are going to break up into 3 2s. Okay, and then you're looking for groups of 3 here. So you have a group of 3 2s, one's going to come out. You have a group of 3 2s, one's going to come out. And then you have this 2 left over. So you have 4 cube root of 2. And once you've simplified that part of it, okay, we're going to take a look at the variables together. So when you have 4, so all I've done is the 128, so just stay with me there. Okay, and then once you simplified the number, now we're going to go to the variables. So A is to the first power, so 3 doesn't go into 1, so the A just has to stay where it is. It can't come out. Okay, and then if you have 5 B's, how many groups of 3 can come out? 1, so 1 B comes out. How many B's would be left inside? 2. 5 minus 3 would be 2. So then your final answer is 4B cube root of 2AB squared. Okay, and sometimes I do just rewrite the answer to make sure I have my notation nice and legible there. All right, now other times you might be given 2 radicals that are being multiplied together. Okay, now I found that the simplest way to do one like that is to multiply across right away and then simplify instead of trying to simplify and then multiply and then simplify again. Okay, so we're going to multiply those together first.
Yep. So for part E, where is the B?
So if you have B to the 5th, then you can take out one group of 3. So if you have, this is B to the 5th here, if you have the cube root, like B times B times B times B times B, so that one group of 3, we take the cube root of that, that's where the B is coming from. And then you have the 2 left over. So it's really like you're doing the cube root of b cubed times the cube root of b squared. And that part is getting simplified. All right, did you guys already multiply across, or were we unsure how to do that? So if we multiply across, what's 3 times 8? 24. When you multiply x to the 5th times x to the 5th, it's going to be x to the, is it 10 or 25? 10. You add the exponents. Okay, and then y times y to the 6 is y to the 7th. Okay, so see if you can simplify that one. Okay, so again, I like to simplify the 24 by itself. What's the perfect square in 24? What's the perfect square in 24? It's not 8. 4, because what's the square root of 4? What's the square root of 4? Okay, that didn't seem very clear. Okay, so the square root of 24 is 4 times 6. So the square root of 4 becomes 2, root 6. Okay, see how the 6 has to stay inside? So when I'm simplifying this, I'll simplify that first, and then I'll just leave some space here so that when I'm working with the variables, I have room to write them. So this is my 2 root 6, and then I go back, and I remember that I'm looking at my index number. My index number is 2. I just asked myself, how many times does 2 go into 10? 5. Yeah. How many times does 2 go into 7? 2 goes into 7 how many times? 3, because 2 times 3 is 6. So if you subtract 6 from 7, you will get y. Okay, so your final answer is 2x to the 5th, y to the 3rd, times the square root of 6y. Okay, so I know that that answer looks like a lot. That's why we kind of break it down into these steps. Okay, and then we're going to start having some fractions here. You can do it. All right, so once you have a fraction, your first step is just splitting this up. Okay, and this first one I gave you has a lot of review material in it. Okay, like you could do this whole part without me. I know you don't want to, but you could. Okay, so you have the root 7 on the bottom. There's nothing to simplify there. But on the top, you have the square root of 16x squared. What's the square root of 16? 4. Square root of x squared? 1x. So the top becomes 4x. I still have this root 7 on the bottom. Now, just like we did on the front page, we have to rationalize. Okay? If we want to undo a square root, how many 7s do we need? 2. If you want to undo a square root, you need 7 squared. Because remember, the square root undoes the power of 2. That's why the denominator becomes 7. You can also think of it as the square root of 49. That also simplifies to 7. And then the numerator just becomes 4x root 7. Okay, so a lot of that is review. Now we're going to extend. We have the cube root of 1 over x. calm. Okay, so our first step is just splitting this up. All right, and then we're going to simplify what we can. Yep, so is 1 a perfect cube? Yeah, because 1 times 1 times 1 is 1. Okay, so this is 1 over the cube root of x. Okay, I don't want you to go any further than the step I'm going to ask you to do, but I want you to multiply the top and the bottom by what you think, and then we're going to talk about that. Because I think 90% of you are going to multiply by the same thing.
The right thing or the wrong thing?
I guess we will find out.
Then I'm just not going to do it like that. If I don't do it, then I don't like that.
I know, I said just write down the first, I just said write down the first one. Okay, if this is a cube root, should we be multiplying by a cube root or a square root? A cube root.
I don't get backlash if I get it.
You're going to get backlash anyway. It's the first time we're doing this. Okay, so I see some of you still with the square root, okay? So 99% of you multiply by this, which is totally what I expect, okay?
Good.
So pause for a second though, okay? So this is normally what people do, okay? They multiply by this and then they tell me that this is the correct answer. So if you multiply the cube root of x by the cube root of x, let's think about why this isn't x. What's the cube root of x times the cube root of x? And do those cancel? Okay, so then Cody, what do we need to multiply by? Yep, because if you multiply by the cube root of x squared, okay, and that's okay. That's why I wanted to make sure that we understood why that was wrong, because that's a very, very, very common thing to do. Especially, I don't believe I told you it was correct. I said this is what most people did, right? Okay, and that's because, why do most people do that? Because up to now, we've only been working with what? Square root. And if you have a square root, you only need 2. If you have a cube root, you need 3. If you have a 6 root, you're going to need 6. 7. I guess I set myself up for that one, though. Okay, so on the top, you're going to have 1 times the cube root of x squared. Okay, and now these will cancel. Okay, so this is going to be your final answer.
It makes sense, but it's still makes sense, but I don't want
yeah, so it's radicals are all based on that index number. So your index number will change. Okay, and so this one's going to be the 5th root. You'll notice each time we're adapting a little bit more. There haven't been any 2 that are exactly the same. Okay, so whenever we do this, our first step is always splitting this up, the fraction. Okay, when you do this on your own, you're going to have a choice to decide if you want to simplify first or if you want to multiply first. Okay, most people do like to simplify first when they notice that you can simplify here. Okay, so you have the fifth root, x to the fourth. You can't take 5 out of 4, so x to the fourth stays inside. Yep, but it does go into 6. So 5 goes into 6 one time with how many left over? 1. Okay, so you can simplify the numerator. Okay, now based on what we just did here, I want you to write down what you're going to multiply by, and I also want you to make sure that if it's a fifth root, you're multiplying by the fifth root. This is a little different because it's a number, but you can still use your exponents. So remember that in order to cancel out, you need 3 to the power of 5. Right now you have 3 to the power of 1. So then, Caleb, what did you decide to multiply by? The fifth root, yeah, of 3 to the fourth. Good. And then, will you guys double check that you did put the fifth root? Because like I said, I noticed some people the first time around that didn't have that. Now, the reason why we do that, actually, I'm going to give myself a little more room. Okay, the reason why we do that is because on the bottom here, you are going to get the fifth root of 3 to the fifth. And when that happens, it cancels out, and what are you left with? Yes, you are left with 3. Right? The fifth root of 3 to the fifth cancels, you get 3. Okay? Now on the top, when you're writing this out, you are going to simplify this value. Okay? So you're going to multiply 3 out. 3 to the fourth is the same thing as 3 squared times 3 squared. So 9 times 9, 81. Yep. Okay, so this is going to be in the numerator, y. Okay, so this is going to be y, and then when you write these, you want them in alphabetical order, and the number goes in front. So it'll be 81 x to the fourth y. Nope, can't simplify it anymore, so that will be your final. Okay, I know. So let's keep going. I feel like I have to keep stopping to say, shush. There's several problems. This is x to the 8th. So the fourth root of 16 x to the 8th y divided by 5z to the 5th. We're going to keep growing and getting more each time. Okay, so why don't you start by simplifying the numerator. You have the fourth root of 16 x to the 8th y over the fourth root of 5z to the 5th. Okay, this time you can simplify the numerator and the denominator, so try that. Okay, so some of you are looking at the board. I'm not doing anything. You're doing something right now, which is simplifying. Okay, so even if you aren't sure what to do with 16, we should know what to do with the 8, right? How many times does 4 go into 8? Twice, so x squared has to go on the outside. Is there anything to give with y? No, so that's going to stay in. The 4 through to 16 is what? 2. It's a perfect square. Okay, if you factor tree 16, it's just 4 and 4, which is 2, 2, 2, and 2. Okay, 2 to the 4th cancels. Okay, on the bottom, the 4 through to 5, 5 has to stay inside, and then 4 goes into 5 one time with 1 left over. Okay, now think about what you're going to have to multiply this by. I'm going to try to squeeze that in there. It's not going to look super pretty. I'm going to write it here because I don't want to cut that off. Okay, so when you have to the 4th, okay, so if this is 5, how many more 5s do you need in order to cancel out? 3, so it's 5 to the 3rd, 5 to the 3rd. How many more z's do you need? 3. Okay, so when you multiply those together, you have 2x squared, the 4th root of 125y. Yep, so when you are multiplying these, the 5 to the 3rd is just 5 times 5 times 5. Okay, so 5 times 5 is 25. 25 times 5, 125. And then you have y and z cubed. Just put those in alphabetical order. And then remember, in the denominator, there's a few things happening. So when you multiplied here, you guys got 5z, right? But don't forget about this z. You have to multiply those together. Okay, so your final answer is going to be 2x squared, 4th root of 125 yz cubed divided by 5z squared. Okay, this is another one where I want you to start by simplifying the numerator and denominator, but I'm going to help you with what to multiply by because this whole section is going to be without a calculator. And most of you would try to multiply by something that would be very difficult to calculate without a calculator. Okay, so I'm going to help you out a little bit. Okay, so we have the 5th root of x to the 6th over the 5th root of 9y. So when you simplify, 5 goes into 6 one time with 1 left over. Okay, nothing to simplify on the bottom. Now, a lot of people would try to multiply by 9 to the 4th, which would be a very large number that I would not want to multiply without my calculator. So instead of doing that, in this case, yeah, what does 9 break down into? 9 is 3 to the 6th power. There we go. That is what you said? Arnav, can you confirm or deny? Deny. All right, so if we think of that as 3 squared, then we can multiply by something. Okay, so if we think of it as 3 squared, remember, all we need is 5 to get that to cancel. So if I have 2, I'm going to multiply by 3 to the power of 3. Because if you have 3 squared times 3 cubed, it'll be 3 to the 5th. But I only have 1 y, so how many y's do I need? 4 more. Okay, so it's okay if they have different exponents. All you need is something that's going to make the denominator cancel out. Okay, because when we have this for the denominator, that's how you get the fifth root of 3 to the fifth, y to the fifth. Okay, so when you cancel those out, you're going to have 3y in the denominator. Okay, in the numerator, the only thing that's on the outside is going to be x. And then when you're rewriting this, the number goes first. So 3 to the third is 27. I have 1x. I have y to the fourth. Okay, so your homework tonight is a worksheet. If you need to write your work on another sheet of paper, that's fine. You just have to turn that in.